Hello everybody, I'm Akshay Surendra and I'll be talking about bird community dynamics in rainforest fragments, insights from 2 decades of bird surveys in southern India. Forest loss and fragmentation is the new normal. About 70% of all remaining forests on Earth are less than a kilometer from the forest edge. Future forests are likely to consist of smaller rainforest fragments and many more of them. Many protected areas themselves are isolated forest fragments, making it more important than ever before to understand whether diversity in these forest fragments are retained over time. The static picture of diversity in forest fragments is well known. For instance, we know that large connected forest fragments are better than small isolated forest fragments. Habitat quality matters, as does the quality of the matrix. But what about changes in diversity over time? Island biogeography theory predicts that species diversity in forest fragments will eventually reach a dynamic equilibrium. In other words, colonization rates will match up with extinction rates. However, long-term studies that have tracked forest fragments since the event of fragmentation find transient dynamics driven by factors such as extinction debt persisting for over 3 decades. So steady-state dynamics remains poorly understood because it occurs much later. So the question we are trying to ask in this study is, do forest fragments that have reached steady state dynamics presumably retain their biodiversity over time? Or in other words, are fragments of today worth protecting tomorrow? We asked this question using birds as a focal taxa. Here's what we did. We used fixed radius point count sampling to study 19 forest fragments in and around the Valparai Plateau in the Anamalai Hills in the southern western Ghats of peninsular India. We sampled birds over 6 years. In the first 4 years, T.R. Shankar Raman, a co-author on the study, collected the data. Data for 2005 was collected by Hari Sridhar and 2019 by myself. In total, we had 2,223 point counts, averaging at about 340 point counts every year and about 40 point counts every year in every fragment. All the birds we detected were passed into two categories, either rainforest birds or open country birds, based on previous studies from the region. We used three response metrics: species richness, where we controlled for the number of individuals; density, where we accounted for imperfect detection; and compositional dissimilarity, which was calculated at a fragment level across time. We used three kinds of predictors: spatial predictors, habitat quality metrics, and time. We used a linear model with a multiple regression framework to estimate our responses and relationships. Coming to our predictions, in this talk, I'm only going to be talking about the marginal effects of time on response. In other words, all other factors, predictors held constant. In the subsequent figures, you will see subplots as follows. The first subplot will be richness, the second will be density, and the third will be compositional dissimilarity, all of which will be plotted against time. Remember, these are the marginal effects of these responses. We suspect three scenarios would happen. These metrics could decline, increase, or stay constant over time. We predict that under a scenario where fragments are worth protecting, species richness, density, and composition will remain fairly constant over time. However, on the other hand, if the community is unstable, declines in species richness and density over time, then fragments are in trouble. Remember that the fragments that we are currently studying in the Valparai Plateau have been isolated for the past 70 years at least and remain, we suspect, in steady state conditions. Here are the results. The species richness of open country birds declined over time, while the density remained fairly constant. Communities further apart in time were less similar to each other. Rainforest birds, which comprise most of the bird community in these forests, declined in species richness over time, declined in their density over time, and increased in their compositional dissimilarity over time, much like open country birds. It's clear that the diversity of rainforest birds is declining, yet the decline in richness is small at about 6%, while the decline in density is substantial at about 30%. In other words, we're getting similarly speciose but sparser bird communities over the last 2 decades. This has serious consequences for ecosystem functioning, especially the decline in the density of birds. These declines are likely driven by regional and global factors because the fragments themselves are relatively stable. In fact, some of them have been restored. These causes are large scale and therefore likely to persist, but will the effect on diversity continue in the future? It remains to be seen. Yet these fragments are worth protecting because they retain about 94% of the richness even after the last 2 decades where densities have declined. The references, and we have a number of people to thank. Thank you for listening.